Significance of flowcharts and algorithms. There are the things that we've discussed in Module 5. I have shown you how to deal with low-level language using the assembly language to communicate directly to the machine codes. Let us now proceed to the lesson preview. Again, a low-level programming language is a programming language that provides little or no abstraction from a computer instruction set architecture. Commands or functions in the language map closely to processor instruction. Generally, this refers to either machine code or assembly language. So, in short, low-level talks more on the computer codes. The machine codes, just imagine if you have those binaries running your program, then you are directly using the low-level programming to produce the results. Wow! So that's quite faster compared to adapting an IDE or other programming language. That's why high-level programming language was built to become more enjoyable to the end users as well as to the programmers, but low-level programming is power. We also discussed the approach and steps in system integration. Ano ba ang mga yon? Can you still remember that 6 basic steps? So let us review. So those 6 steps are requirements gathering, second, analysis, third, architecture design, fourth, systems integration design, then implementation, and lastly, maintenance. So for the content notes of our discussion today, during your first year of college, you are taught how to use the flowchart. Why? Is it that flowchart is important designing a system? With flowcharting, you can construct a guided flow of your design, plus a careful analysis of your codes. A flowchart is just like a conceptual map. Parang hakbang ng mga data yan. While you are illustrating the flowchart, you get familiarized with pseudocoding. They are written not technically patterned to programming jargons, but in a very plain English to be understood by the programmers and the data analysis. Algorithm is pseudocodes or equals to flow charting. So flow charting is the fundamentals of designing the flow of the program. For me, this is not basic because every programmer should know this or should use this, okay, as a tool for designing a system. You are using the input process. In the process, we have validation, control, loops, decision support, data bank, validation, etc. And lastly, outputs. So for the algorithm and flowchart are powerful tools for learning programming. An algorithm is a step-by-step analysis of the process, while a flowchart explains the steps of a program in a graphical way. Algorithms and flowcharts helps to clarify all the steps for solving the problems. When you are trying to create something, a design for calculator that sends factorial results to the computer, you are not actually writing the codes, but the algorithm or the flowchart. How? So first, create a problem-solving flowcharts. So these are the steps and procedures on how to create a flowchart. So first, draw a starting shape to state your problem or task. Second, draw a decision shape where you can ask questions that will give you yes or no question. And third, based on the yes or no answers, draw arrows connecting to the possible paths you can take to work through the steps and individual processes, as being shown in our screen. So we have here the starting and then the ending process. So to avoid buffing thoughts, there are the basic example of view flowchart. So that will be provided in a separate links for you. So the relation of a flowchart to an algorithm is so tight. If you refute this, then send me a message again. There are no standard algorithms. The algorithms dictate the idea of perfecting the steps of the data flow. If you design a project like a calculator that sends the data to the file or to the Android device, then algorithms and flowcharts can help you. Now, the question is, sino ang mauna? Whose comes first in the flowchart on algorithms? I will answer this based on my experience. In the industry, in my terms, I always write first the algorithm and box it with flowcharting. Why? I just want to repeat this again. Again, an algorithm is a step-by-step analysis of the process, while a flowchart explains the steps of program in a graphical way. For beginners, it is always recommended to first write an algorithm and draw flowchart for solving a problem, and then only write the program.
In this video, we'll show you how to create a flowchart in Microsoft Word. Let's say you want to document the process that happens after a user has provided the username and password to log in a website. First, we will define the process and later on change the shapes to make it look like a flowchart. Let's move to the Insert tab and click on the Smart Art button. For showing a decision tree, we can move to the Hierarchy category and select the Organizational Chart option from here. In the text box, let's remove the default text first. Now let's start defining the process. The first shape will represent the start of the process, so let's simply type in Start over here. Once we hit Enter, the next shape will appear. To connect it with the first process, let's hit the Tab key on the keyboard. Now this shape will be a decision with two outcomes, whether the username and password entered was correct or not. After we have entered the decision, let's move to the next line. Hit the Tab key and write Yes and No in two different lines. Now each outcome has an action. So for example, let's go back to Yes. Hit the Enter key, then the Tab key, and let's write the outcome we want, which is that the user will be logged in the system. Similarly, we will add an action for the other outcome as well. Last of all, we will end the process after both outcomes. Now let's make it look like a flowchart. For that, we will select each shape in the Smart Art and change it. So let's select the Start and End processes. Move to Format and click on the Change Shapes drop-down menu. The oval shape, or the Terminator symbol, is used to represent the start or end of a process, so let's select that. Next, for the decision, we will use the diamond shape, which will have two outcomes. The rectangle shape represents the process. Since the remaining shapes are processes, we will keep them as is. Lastly, let's select all the line shapes and change them to arrows. Within the Format tab, Let's open up the Shape Outline drop-down menu. Move to Arrows and click on this option here. This is a basic flowchart, and you can use all the formatting features available in Word, whether for text or shapes.
That includes our content notes. So for the skill building, we have a separated discussion for this and demonstration, and as well as for the checking for understanding. So now for the frequently asked question, what are the types of algorithms? So what are those types? So we have the simple recursive algorithms, backtracking algorithms, divide and conquer algorithms, dynamic programming algorithms, greedy algorithms, branch and bound algorithms, brute force algorithms, randomized algorithms. Okay, so thank you so much everyone, and see you next time.